Hello students, in this video we'll discuss inverse matrices. Let's suppose that A is an n by n matrix. Okay. We say that B, which is also an n by n matrix, is the inverse matrix of A if A times B is the n-dimensional identity and B times A is the n-dimensional identity, like so. Okay. Now, it's not always the case that matrices will have inverses, but when they do have inverses, we'll try and investigate a procedure for how to find them, right? So just as a remark, note, not all matrices have inverses. Okay, and so here's an example of that. So example, if I consider A, which is this matrix over here, so I have an extreme case, 1, 0, 0, 0. That's a perfectly fine matrix. But if there was going to be a matrix that multiplied to give the identity, let's suppose that we could find one of those matrices. Suppose that if that was my A, I could find a matrix B, which was A, B, C, and D, that gave me the identity matrix, like that, because I had to output the identity matrix. So in other words, A times B would be equal to this two-dimensional identity. Okay, so in other words, let's see if we can find an inverse for this matrix A. Well, let's look over here. So if I do A times B, what am I going to get? I'm going to get what? I'll have an A over here, then I'll have a B over here, then I'll have a 0 over here, then I'll have a 0 over here. So A times B is AB 0, 0, and I can see that that can never be equal to the identity, right? So these things cannot be equal to each other because there's the second row over here is 0, and the second row over there is just a 0 and a 1. So it's impossible. So there's no inverse of A. So A inverse, so A is not invertible. Okay? Now, thankfully for 2 by 2 matrices, there's a very simple rule for invertibility, right? And so here's a proposition, simple proposition. So let A be the matrix A, B, C, D, okay? And AD minus BC is not equal to 0, okay? So I'm assuming that AD times BC is not equal to 0. For those of you who have seen some more advanced topics, or maybe you've seen this in another class, this is really just the determinant of the matrix A. So the determinant of the matrix A cannot be equal to 0 for this result to be true, okay? Then, if this is so, then A inverse is given by this formula. It's 1 over this quantity, AD minus BC, times the matrix D, negative B, negative C, and then A, okay? Of course, the proof is straightforward. What I'm going to do is let me just multiply this matrix over here and this matrix over here. So if we do that, if we do AD, A, B, C, D, times the matrix D, that should be a B actually, that should be a D rather. It's going to be a D. That's going to be a D, negative B, negative C, A. What are we going to get? We're going to get AD minus BC up top, AD minus BC. Then over here I'm going to have a negative AB and a positive AB, it's going to give me a 0. And then I have a DC and a negative DC, it's going to give me a 0. And then I'm going to have a AD minus BC. And so I see, therefore, if I divide by this AD minus BC over here and over here, I'll get the identity matrix. So if I do 1 over AD minus BC, I would do the whole matrix divided by 1 over AD minus BC. That would just turn into what? That would just turn into 1, 0, 0, 1. And we've just verified that this is the inverse of a 2 by 2 matrix under the assumption that AD minus BC is not equal to 0 in this case. Okay? Excellent. Now the question becomes is how do I determine if the matrix A is invertible in general? So in general, what's our procedure going to be? In general, what do we want? I want to find a matrix B at like A times B to be the identity matrix over here, like so. And so what I need to do is, of course, the columns of this thing, so I need the A, B1 is going to be equal to what? It's going to be the first column of the identity, which is going to be E1, hat. So remember that EJ hat is the standard basis, so it's going to be 0, 0, 1, 0, 0, and that 1 over here is in the jth entry. Jth entry. Okay? And analogously, all the way down to ABN is equal to EN hat. So I have this augmented system over here. What I really like to do is I'd like to say I have an augmented system of equations. And so what can I do? What I can do is I can take my matrix A, and I want to augment A with what? With the identity over here. Okay? And then I want to do row operations. So if we can put this into reduced row echelon form. So if the reduced row echelon form turns into what? Turns into the identity times B. That will have solved our equation to find what the inverse of that matrix is. So this matrix B over here is going to be the inverse of A. If and only if what I get here by reduced row echelon form is the identity. So if that's reduced row echelon form, it gives me the identity, then this B will be equal to A inverse. However, if this is not the identity, then A will not be invertible. If this turns into not the identity, B, that implies that A inverse does not exist. And we'll see applications of this in further videos, but a great thing to check is to take this matrix over here, perform row operations to get the identity over here, and verify that that's the formula that you'll get when you do the inverse. Thank you very much.